You must be knowing about refraction of light, which takes place due to change in the speed of light as it enters from one transparent medium to another, having different optical densities. Let's understand the phenomenon of refraction of light through an experiment with the help of given materials. Fix a paper on a wooden board with the help of board pins. Place a rectangular glass slab in the middle of the sheet. Take the pencil and draw the outline of the glass slab. Name it as ABCD. Now, remove the glass slab and draw a line IO inclined to edge AB. IO is the incident ray. Draw a normal N1, N2 at the point of incidence O. Take two pins, P1 and P2, fix them on the incident ray IO. Place the glass slab again on its initial position, that is ABCD. Looking from the other side, CD of the glass slab, fix two pins P3 and P4 such that these two pins and the images of pins P1 and P2 lie on a straight line. Now remove the glass slab and the pins. Encircle the pin pricks of P1, P2, P3 and P4. Join the points P3 and P4 and extend the line to meet the edge CD at point O'. O'E is the emergent ray. Join O'. The ray O' is the refracted ray. Draw a perpendicular M1, M2 to CD at O'. Measure the angle of incidence I, angle of refraction R, and the angle of emergence E. What do you observe? It is observed that the angle of incidence I is greater than the angle of refraction. R and angle of incidence is equal to the angle of emergence E. When the emergent ray O'E is extended backwards, you will notice that it is parallel to the incident ray. Do you know why? It is due to the fact that at the opposite parallel faces of the glass slab, the maximum bending of the ray of light is equal and opposite. However, the emergent ray is shifted slightly sideward. This displacement is known as lateral displacement. Lateral displacement increases with the increase in the thickness of the glass block, angle of the incidence, and refractive index of the medium. From the experiment, it is observed that the light bends towards the normal when it travels from air to glass, that is from rarer medium to denser medium, and away from the normal when it travels from glass to air, that is from denser medium to rarer medium. On the basis of several experiments, it is concluded that the refraction of light is based on two laws. The first law states that the incident ray, the refracted ray, and the normal to the interface of two transparent media at the point of incidence all lie in the same plane. And the second law states that the ratio of sine of angle of incidence to the sine of angle of refraction is a constant for the light of a given color and for the given pair of media. This constant value is called the refractive index of the second medium with respect to the first. This law is also known as Snell's law of refraction. The Snell's law is true for angle of incidences between 0 and 90 degrees. Do you know how a light ray is affected if it incidents normally to the interface of the two media? The light ray will pass undeviated, but its speed will vary.